Thank you very much. Thanks to the GRDC for having me here. And I hope that everybody can understand me. I actually had to fly 14,000 kilometers to figure out that I had an accent. So today I'm going to talk to you about the Canadian and Australian canola industries and our similarities. Our fathers of canola were your uncles of canola. Many of the research projects that we've had in Canada, you've also had in Australia. Our problems are your problems. So the talk will examine canola improvements in Canada, specifically the Canadian prairies, and I'll talk to you a little bit about Canadian agronomy and new methods. Okay, Canada's a vast country. We have nearly 1 billion hectares of land. We only have about 68 million hectares of farmland, and of that, only about 35 million hectares is cropland. The rest of it is rock and bog and pine forest. And about 81, I always do this the first few times. About 81% is located in the prairies, another 14% in Ontario and Quebec, and the rest is spread out through Atlantic and Pacific Canada. These are the major soil zones of the Canadian prairies, and I'm going to focus on the Canadian prairies because that's where 99% of the canola is grown, in the provinces of Alberta, Saskatchewan, and Manitoba. These are the soil zones. They go from a light brown textured soil, and as you move north and as you move east, the soils become heavier in texture. That's because they have more clay content and they have more water holding capacity, more organic matter. The majority of canola is grown in the dark brown, black, and dark gray soil zones, but now more canola is moving into the light brown soil zones. This is Canadian field crop production in thousands of hectares. I have 3 colored bars here. Yellow represents no change since 2009, red a 10% decrease, and green a 10% increase. Well, wheat has stayed about the same at around 10 million hectares. Canola is catching up, over 8 million hectares of canola. Soybeans also increasing, the same with flax, and they're doing this at the expense of the traditional cereal crops, barley, oats, and rye, and tame hay. This is hay that's baled, not really hay that's pastured. These are the Agriculture and Agri-Food Canada stations and substations spread throughout the Prairie provinces. We have 3 zones of canola production. The short season zone in the north, that's about 90 to 95 days. The mid-season zone, 96 to about 104 days. And the long season zone, 104 to about 112 days. Now I've picked 3 stations to show you the typical climate patterns. They're Beaver Lodge in the north, Scott in Saskatchewan, and Morden in the south of Manitoba. So this is a continental climate, which means that there's cold winters with temperatures less than -3 degrees, warm summers, not hot, and the majority of the precipitation falls during the summer months. So average growing season precipitation in Beaver Lodge is about 235 millimeters. In Scott, about 216, and in Morden, about 305 millimeters. This shows you the difference between canola growing in Canada and canola in Australia. We cram our crop into 4.5, 5-month period, and we plant between frosts. So the last spring frost and the first fall frost, we try to get our crop in. So this takes 95 to 112 days. In Australia, you also seed at the end of April, beginning of May, but you don't harvest until the end of November, beginning of December. So you have twice as long to grow canola as we do. So this slide just shows you canola plants taken about 15 days after seeding, and I'll set this in motion. So by 30 days after seeding, we have a full canopy. By 35 days, the crop's about to bolt. It flowers. And by 50 days after seeding, we're at the point where we have about 10% bloom left, and the pods are just starting to develop on the terminal raceme. So, very narrow window. This is canola production in thousands of tons. Okay? So, in 1986, we produced about 3.8 million metric tons of canola. The Canola Council of Canada, a farmer organization, had a target of producing 15 million metric tons of canola by 2015. That's been exceeded. They have a new target of producing 26 million metric tons of canola by 2025. But I really don't know where they're going to put it all. Price has really driven the increase in canola. This is price for oil, meal, and seed, and that has been increasing. And we all know that farmers deserve and really like a good price for their crop. This is a Prairie farmer canola yield in tons per hectare. So from 1986 to 2013, yield increased by about 2.4% per annum, or about 65% in total. I prefer to cut this graph in half, compare lines up to 1999 and lines post-1999. This is because up to 99, we had open pollinated varieties, hybrid varieties, some with herbicide tolerance, others without. Post-1999, over 80% of our varieties are hybrid with some herbicide tolerance linked into it. And this is a period I'm going to concentrate on. So from 2000 to 2013, yield increased by 695 kilograms per hectare, or 55 kilograms per hectare per annum. That's an increase of about 4% per annum. And the rest of my talk will really focus on what has caused this yield increase. Now remember, this is farmer yield. This isn't experimental plot yield. So we all know that yield is a factor of the genetics, the genotype, the environment, and the management, and all these interactions of these three main factors. There's lots of things we can control, but there's many things we really can't control. This is the conversion from open pollinated varieties to hybrid varieties with herbicide tolerance. In 1992, the federal government said there's no more federal plant breeding of canola. The private companies have taken over. In 1995, the federal government said it was okay to plant genetically modified canola in the field. And there was a huge increase in the number of open pollinated varieties with some herbicide tolerant linked in. And by 1999, 80% of all varieties are hybrids with some sort of herbicide tolerance. By 2014, 95% of the varieties are canola hybrids, and mostly Roundup, some Liberty, and a little bit of Clearfield. Has that switch to hybrids with herbicide tolerance hurt our exports? Well, the answer, I guess, is no, it hasn't. Our exports have continued to climb. Our trading partners have changed slightly since 2003. We now focus more on China and Asia, Japan, other Asian countries, less on a percentage basis to Europe, and less on a percentage basis to United States, but we're probably exporting just about the same amount. I really think that bigger threats loom on the horizon to canola, with things like high oleic soybean oils coming on production in about 5 years. So to estimate genetic gain, what you need is a performance trial, like your NVT, what you can do, if you have one open pollinated check that's planted for several years, you can compare the increase of the new varieties to this open pollinated check. And this is what this is. This is the increase above the open pollinated check, and these are the years. And when you look at this, you get an increase due to the switch from open pollinated to hybrid at around 2.4% per annum. Another main factor is environment. Last year was supposed to be the hottest year on record, so you really have to look at temperature. And this is what I did. I took my 10 prairie sites and I looked at average temperature during the year. I looked at growing season temperature. I looked at stress temperatures, things like temperatures over 30 degrees or temperatures during vegetative development under 10 degrees. And I couldn't find any relationships with temperature and this 13-year period. I did find a really good relationship between precipitation during the months of April and May and this 13-year period. Precipitation increased by about 4 millimeters per year, and yield increases by about 4 kilograms per millimeter with April and May precipitation. This is just when we're establishing the crop, and farmers say that if you can get 3 good rains in May, that sets your crop. So precipitation has been increasing yield by about 16 kilograms per hectare per annum. But precipitation doesn't sit by itself. It interacts with management. You can put all the nitrogen in the world on your canola, but if you don't have precipitation, you can't use it. Another environmental factor is carbon dioxide. Carbon dioxide is increasing. This year it's supposed to be over 400 parts per million. And plants react with carbon dioxide. It's the fuel that's used in photosynthesis to produce glucose. More glucose, more plant matter, more yield, better water use efficiency. So from 2000 to 2013, carbon dioxide increased by about 25 parts per million. A study done in Europe where they grew canola outside, put a tent around it, and increased the carbon dioxide showed that canola responds conservatively to each part per million by increasing yield by about 1.7 kilograms per hectare. So when you do the math, you get that just due to carbon dioxide, yield increased by about 3 kilograms per hectare per annum. So if you could make a balance sheet here of the main effects, genotype, environment, and management. Here's our yield improvement of 695. 59% of that was due to the development of new varieties. 29% due to precipitation, 6% carbon dioxide, and when you do the math, you get about 6% just due to management. Now, I'm an agronomist. When I first did these calculations, I quickly redid the calculations and did them again, and I couldn't believe that it was only 6%. I asked myself, why is management effect so small? So I did a lot of thinking, and I really came to the conclusion that many of these best management practices for growing canola were in place prior to the year 2000. Things like the conversion from tillage to minimum tillage, or the use of fertilizers, the amount of fertilizers to use, the seeding rates, the herbicides, and so on. I also believe that not all prairie farmers use the best management practices. Finally, there's these interactions, the genotype by management, the environment by management. These are hidden underneath the main effects. They're not easily determined. I do believe that management will need to keep pace with new hybrid variety development. This is a test done by Bob Blackshaw at Agriculture and Agri-Food Canada in Lethbridge. He compared a full input package to an empty input package. And to the full input package, he removed some of these treatments. To the empty input package, he added them. And the treatments were either a hybrid or an open pollinated variety with Liberty linked in, 75 or 150 seeds per meter squared, 3 rates of fertilizer, and 3 rates of Liberty. And these are his results. This is the, This is the full package, 2,500 kilograms per hectare. This is the empty package, about 750 kilograms per hectare. When you remove inputs, when you remove 50% of the fertility, you reduce yield by 11%. 13% goes down when you take out the genetics, when you switch from a hybrid to the open pollinated, and so on. So he was able to rank these inputs. Herbicide first, fertilizer, which was about the same as genetics, and finally seeding rate. And when you add to the empty package, it's only when you add herbicide that you start to see a yield improvement. And this is Bob's spreadsheet. So when you change the genetics, you increase yield by about 179 kilograms, the seeding rate, fertilizer, herbicide, and when you total these up together, you get 1,248 kilograms per hectare. But the total yield, the full package yield, was 1,764 over the empty. So this means that the interaction was 516. Nearly 1/3 of the entire yield is due to the interaction of our management factors with environment. On the prairies, they recommend that you grow canola every 3 or 4 years. This is to reduce weeds, it's to decrease diseases in your cycle. Now, crop rotation is a very integral part of integrated weed management. But farmers, they like the herbicide-tolerant varieties, and they're getting a high economic return. So really, they're shortening their rotations. And 70% have recently admitted in a survey that they've shortened their rotation from 3 or 4 year down to about 70%, down to about 2-year rotation. So Bob and Lethbridge and Neil Harker did a study where they looked at separating canola by different years in either a pea, barley, or wheat rotation. And they found that when you used a 2-year rotation, your yields increased by about 9 to 14%, and a 3-year rotation resulted in a yield increase of 15 to 17%. 15 to 27%. So this shows you that rotation, and the longer you can rotate, the better. And this is really the reason why. I don't know if you can see that back there, but this is canola grown every year, and as opposed to canola grown every 3rd year. Blackleg, we have a problem with blackleg just like you do in Australia. Blackleg increases when you reduce the number of years between rotations or between canola in your rotation. So blackleg goes from 29, 32 to 43% for a 3, 2, and 1 year separating canola in rotation. Here's a study by John O'Donovan in Lacombe, just up the road from Lethbridge. And he grew these crops in the field, and the following year he went back in and sowed canola into the field. This was done all over the prairies, about 6 different sites. He found that canola after wheat, you got 2,289 kilograms per hectare. That's the standard. When you use a green manure, you really increase that yield. When you use either a field pea or lentil, you increase yields by about 10%. So canola after a grain legume had about a 10% yield improvement over canola after wheat. He also used about 5 different rates of urea, and he found that you could reduce the amount of urea when you included a grain legume in rotation by about 25%. Here's some small facts about nitrogen. Farmers on the prairies can test for nitrogen in the fall before freeze up, or they can test in the spring before planting. Fertilizer is banded beside the seed and below the seed. You can't place very much fertilizer with the seed or else you reduce emergence. 2012 Canola Council of Canada survey of farmers, the farmers said that they apply nitrogen primarily based on past experience, their soil tests, the general fertilizer guidelines, and cost. And we've also found that wheat after hybrid canola needs more nitrogen than wheat after open pollinated canola. Some work with polymer-coated urea found that it did not improve yield over regular urea when banded beside and below the row. Bob Blackshaw showed that new hybrids are able to tolerate up to 150% of the recommended nitrogen rate. So they can use more nitrogen than the open pollinated types. But geez, I keep on doing this. Are they more nitrogen use efficient? So 3 studies, one showed that they were more nitrogen use efficient. The other said, by the same guy, said that they were about the same. And the third one said that open pollinated are more nitrogen use efficient than the hybrid. So this really tells me that in the future, we're going to have to continue to do work on fertilizer with new hybrids. Most of these studies were done with hybrids that were released in 2002 and 2003. Polymer-coated urea with the seed, you can put up to about 30 kilograms per hectare of polymer-coated urea without reducing emergence. There's 30 kilograms of urea. You can see the reduction in emergence. Another test showed that you can put about 60 kilograms of polymer-coated urea with the seed without yield damage. This brings up the question of, can we apply the right amount of fertilizer based on what the crop is telling us that it needs? This is variable rate nitrogen application, some work done by Chris Holzapfel and Guy Lafond at Indian Head. So these are 2 plots of canola, both just at bolting. This received no nitrogen, this received 200 kilos of nitrogen. So our eye can see the difference. And we can use a sensor like this green seeker to also see the difference. The green seeker is an active sensor. It emits a beam, and what's reflected back is measured, and it really looks at the green color of the canopy, which is correlated with chlorophyll, which is correlated with nitrogen concentration. And it spits out units called NDVI, which is Normalized Difference Vegetative Index. It goes from 0 to 1. So you can use a lot of different fertilizer rates and get these lovely curves. Then you can plot NDVI versus grain yield, get another lovely curve. When you do this over a lot of different locations, you get a curve that can be standardized. This curve can then be used in a crop computer to control a variable rate application of liquid UAN to the crop. And this is what they do. There's sensors on this bar. It's used to map the field. It's used to map the field here. And the dark green areas are areas with abundant nitrogen. The yellow areas are areas with low nitrogen. And the idea is put nitrogen on where it's needed. You wouldn't put nitrogen on these areas, you're not going to get a response. You would put nitrogen on the light green areas, and perhaps you would put even the same amount of nitrogen on the dark green areas to increase your yields. So Chris went out to farmers' fields, and this is what he did. He mapped the farmers' fields and he compared variable rate application with farmer practice nitrogen. Farmer practice nitrogen was 100% of what the farmer would put on at seeding, and Chris used variable rate nitrogen, which was 66% of what the farmer would put on at seeding. And then at bolting, he used the equation and the green seeker to adjust the amount of nitrogen that he was going to put on his crop. So he found that 6 out of the 9 fields used less nitrogen with variable rate than farmer practice, There were no fields that yielded significantly less with variable rate than farmer practice. And economically, variable rate application actually put more money back into the farmers' pockets because they were applying less fertilizer. But there's a problem. You've seen how fast our crops grow. We have a very narrow window to apply fertilizer. If we're trying to hit bolting and we have a rain event or something like that, the farmer's delayed, the crop has flowered. Also, this isn't used extensively. There's not a lot of coffee shop talk about it. Farmers aren't adopting this technology. Farmers complain about the high cost of hybrid seed, and they're always asking, can we reduce the population to save some money? But for us, uniform emergence improves yield, it competes with weeds, we optimize our harvest, and we improve our seed quality with uniform emergence. But in Canada, we have a problem. Even when you use 95% germination rate seed, we only have 50 to 60% of the seed emerging. So Neil Harker's done some experiments where he's taken seed and screened them to get 4 different seed size categories. When he put those in the ground, there was no effect of seed size on emergence, nor was there an effect of seed size on yield or seed quality. He did find that large seed produces a more vigorous vegetative canopy, which can outcompete with weeds. Neil experimented with planting speed and depth. And when you slow down and plant at 1 centimeter, you increase emergence and high seeding rate at high speed and high depth decreases emergence. This is at 150 seeds per meter squared. Planting density, producing plants per meter squared, and the relative yield of treatment. This was done by Murray Hartman and Neil Harker, and it was a meta-study. So each one of those dots represents a study of population density. You can look at this. This is the odds of obtaining the maximum yield from your plot or your field. So what you want is 100% of the time you're going to obtain maximum yield. When you have low population density, you increase the chances that you aren't going to obtain maximum yield. So between 60 to 100 plants per meter squared, that's where you're going to obtain the maximum yield. And remember, this is basically obtained by seeding 120 to about 150 seeds per meter squared. So in summary, Prairie yield gain of 4% per annum has been made primarily with the development and adoption by farmers of hybrid varieties with some herbicide tolerance linked in. Hybrid seed is purchased every year. It's treated with fungicides and insecticides, and the old adage that we learned in Agronomy 101, good seed means good yield, it holds. Nature really gave farmers a big boost by increasing the amount of spring rains. I really ask the question, how high can hybrid canola go? How high can the yields go? Corn hybrids have increased about 5-fold since they were introduced in the 1930s. And really, we haven't even seen 1-fold increase. Almost 1-fold increase since hybrids were introduced for canola. Management will need to be revised with new hybrid varieties. Variable rate nitrogen application works, but for us the timing is really tricky, and it's not widely adopted by farmers. We need to improve emergence and stand establishment. Our ideal plant population is around 80 plants per meter squared, achieved by seeding 150 seeds per meter squared. Bigger seed does not translate into bigger yields, and slower and shallower seed placement is best. I have a lot of people to thank for my appearance here today. The Grains Research Update, GRDC, Canola Council of Canada, CSIRO, and my organization, Agriculture and Agri-Food Canada. And I thank you for listening to me. And if you have any technical questions, perhaps I can answer them at the back chat. Thank you.